Hello everyone, today we are learning about systems of equations. We're going to focus on doing it graphically, and in tomorrow's lessons we will look at it in the algebraic point of view. So the first graph we have is x plus 2 squared plus y minus 1 squared is equal to 5. So this one is a circle function or a circle equation that we have, and when it comes to like graphing a circle, we need our center and we need our radius. So let's take a look. So we need our center, which we're going to take from here. The positive 2 turns into a negative 2, and the negative 1 turns into a positive 1. And I'm going to go ahead and plot that right away. Negative 2 comma positive 1. Then we have to find our radius. So we're going to use this 5. Technically, this 5 is radius square. To get the r by itself, we're going to take a square root, which is going to give us a radical 5. So now radical 5 is not a whole number, but that's fine. We're going to work with the decimal, and the radical 5 is approximately 2.2. So that's the we're going to keep in mind when we are doing the graph. So like approximately 2.2. So what we're going to do is from the center, we're going to go 2.2 to the right, 2.2 up, 2.2 down, and 2.2 to the left. And then we go ahead and then we try to connect the dot as nicely as we can with freehand. And you can also use your compass too if you want to. The second equation that we have, this one is a linear function. And I know that because x is to the power of 1. So we have x minus 2y is equals to negative 4. We have to get the y by itself. So I subtract x on both sides. I get negative 2y is equals to negative x minus 4. And then I divide by negative 2 on both sides, which ends up giving me a y is equals to positive 1 over 2x positive 2. So you could put this in the calculator and plot the points. I am going to use do rise over run to do it. So I have positive 1, positive 2 is my slope. From there I go up 1, right 2, or I could go down 1 and left 2, down 1 and left 2. And I think this is good enough for like points. So we can go ahead count connect them, and you just keep extending the line as much as you can. And I will do the same on the other side as well. Okay, and the 2 points where they connect is at 0, comma, positive 2, and 1, 2, 3, 4, negative 4, comma, 0. So those are our 2 intersections, so 2 solutions. The intersections are the 2 solutions. And for us, that is negative 4, comma, 0 and 0, comma, 2. And that's it. That's our answer. And I went ahead and I graphed it on the Desmos calculator. And notice for the Desmos calculator, I didn't even get the y by itself, and I plotted it just the way it is. And if I click on like the intersection 0, comma 2 and negative 4, comma 0, and that's our answer. Unfortunately, like when it comes to like circle functions, you cannot graph them on like a TI-84, so you really need to know how to plot the points for that. Okay, all right, that being said, let's take a look at our next one. Next one, once again, we have a circle and a linear situation. Now for this one, for circle, we don't see any number next to the x squared. So that means the center for the x is going to be at 0. And the negative 4 turns into a positive 4. So that's what I'm going to go ahead plot 0, comma 1, 2, 3, 4. And then from there, the radius, we're going to do a radical 90, and let me put that in my graphing calculator. Radical 90 is equal to a 9.4, so approximately, well, 9.5, I guess, so approximately 9.5. approximately 9.5. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So and then we have another about 1, 2, 3, 4, 5, 6, 7, 8, 9.5. 1, 2, 3, 4, 5, 6, 7, 8, 9.5. So like if we go up, it's not going to fit, and that's okay. We'll just try our best that we can. It's going to go outside of the graph, and we'll just leave it like that. Oh wow, it's looking like a pentagon. Okay, not the graph I want, so I think I can't make it look nice. I think I just have to. And that's okay. That does happen sometimes. It doesn't fit, and it's not going to like ruin your solution set or anything like that. So let's see. We have to get the y by itself. So subtract x on both sides. We have 2y is equals to negative x minus 7, divide by 2, divide by 2, divide by 2. And then we end up having y is equals to negative 1 over 2 minus 7 over 2. So 7 over 2 is about 3.5. So let's see. Negative 3.5 is at 1, 2, 3, negative 3.5. And then from there, we're going 1 down and right 2. So this one, let's see, 1 down. Then we have right 2. And then, or we could do 1 up and left 2, 1 up and left 2, 1 up and left 2. So this one's a little bit tricky, but we will make it work because they're like all like kind of like decimal numbers. But seems like we kind of have it with our free sketch, but I'm going to put it in our Desmos calculator just so like we can verify exactly what we are seeing. So I'm going to go to y equal, I'm going to clear out what I have, and then I'm going to input our function. So we have a x squared plus let's see, y minus 4, and then to the power of 2 is equal to a 90. So we also see in here, it looks pretty big too. And then we're going to add our next one. You could put it as like y equal, or you could just put the original. I'm just putting the original. Doesn't matter. In Desmos, you could put it like either way, but in your graphing calculator, you always have to make sure you set it as y equal. So we kind of have like the solutions that we see. It's like 3 comma negative 5. We almost have it here, but it's because we like did like freehand sketch, so it doesn't look as obvious. So this is 3 comma negative 5, and then the other one is negative 9 comma positive 1. So in this situation, it was like a little bit shaky to see it more accurately. So to make it more accurate, what we do is like in these kind of scenarios, I would recommend solving it algebraically, but that is something that we focus on in the next video. So for now, you can go ahead, take all the notes you need, and I will see you all tomorrow.